All right, we're doing 10.2, lecture video B. The meaning of a to the negative m over n. That is whenever you have a negative exponent, you put it under 1 to make it positive, where a cannot equal 0, because if a was 0, you would have something that is undefined. So here we go. We are going to use, remember, you can write these as radicals if you want to. And if you were to write them as radicals, the denominator tells you what index it's going to be. 81 to the negative third power, all right? So this numerator will tell you what the exponent on 81 is. The denominator will tell you what the index is. That is only if you want to use radicals to help you simplify it. So you would have the fourth root of 1 over 81 cubed. Now you would have the fourth power of 1 over, now I'm going to make that 4 to the, no, not 4, 3. 3 to the fourth power is the same thing as 81, exact same thing. Now, I need to have it as to the fourth power, so I'm just going to interchange those because it doesn't matter. It means the same thing. 1 over 3 to the third power raised to the fourth power. It's okay if I switch them because commutative property says that 3 times 4 is the same thing as 4 times 3. Now, the reason why I need them to be in the fourth power is because I'm taking the fourth root of them. Now, 1 to the fourth power is just 1, so I can actually put a 4 right there. It does not matter. So the fourth power of 1 to the fourth is just 1. The fourth power of 3 to the third raised to the fourth power is just 3 to the third, which gives me 1 over 27. Now, that is a lot of work. Let me show you what would be an easier way to do this problem. Well, first of all, I have 81 to the negative 3/4. Now, remember, the number 81, I can do so many things with it. I can break it down to 9 squared. I can break it down to 3 to the fourth if I want to, and that's what I'm going to do. I'm going to break it down to the smallest numbers I can. I know that 3 to the fourth is the same thing as 81. So what I'm going to do right now is I'm going to make this 81 to the negative 3/4. Now, when you raise a power to a power, you multiply the exponents. So my base is 3. 4 times negative 3/4. My 4's cancel out, and I'm left with negative 3. So that's going to be the exponent on this. Now, we've learned from a long time ago, we're not allowed to have a negative exponent. So I'm going to put it under 1. So now it becomes positive, and that is where I get the 1 over 27. Now, you guys can decide which one is easier to do. It is your choice. I personally am going to use exponential because that's what they want us to do. Now, on the next one, again, I'm going to reduce 36. So my power is negative 3/2. I'm going to make 36. We all know that 6 squared is the same thing as 36. We have 36 raised to the negative 3/2. Now, first of all, when you raise a power to a power, you multiply the exponents. So 2 times negative 3/2. Again, the 2's cancel out, and you're left with negative 3. So 6 to the negative 3 power. We cannot have a negative exponent, so we're going to put it under 1. Now, normally they won't probably leave it as 6 to the third power. They're going to ask you to actually multiply it out. 6 times 6 is 36. 36 times 6 is 216. So that would be your answer. Now, the next problem. you have some options here, but we're just going to do it step by step. First of all, I have 64 to the negative 3 halves, and I have 25 to the negative 3 halves. I broke it up into each, the numerator and the denominator. The outside portion is still negative 3 halves. Well, I know 64 can be broken down into 8 squared. 8 times 8 is 64. I know 25 is 5 squared. So this is really 25 and this is really 64. So I did nothing but manipulate. Now, my numerator, my base is 8. 2 times 3 halves. The 2's cancel out and I'm left with a negative 3 as my exponent. In the denominator, I have 5. The 2's cancel out and I'm left with negative 3. Now, when you have a negative exponent, if you have a negative exponent in the denominator, you move it to the numerator. If you have a negative exponent in the numerator, you move it to the denominator. So on this one, I have 5 to the 3rd power up here, and I have 8 to the 3rd power down here. By switching them, it changes the exponents. So now I get 125 over, I have no clue what that is. So 8 times 8 is 64. 64 times 8 is 32. Carry the 3. That's 48 for 9, 50, 51. 512. Okay, they might have left this as your answer, but I broke it down. Okay, let's move on to the next one. The next one is still using rules for exponents. So basically, when you raise a power to a power, you're multiplying the exponents. Now, in this case, all they did was they kind of just changed these around. You're just multiplying 1n times m, which is the same thing as m times 1n. It's the commutative property. It's just you can switch the values. They're just products of each other. And so here we go. Let's go ahead and do the actual problems. It just makes it a little bit easier. Write each exponential as a fraction. So we're just going to be writing them down. We're not solving for anything. Remember, the denominator is your index. The numerator is your exponent on the 19. So this is going to be the square root of 19. If it makes it easier for you, I will put a 2 here and I will put a 1 there, because you don't have to do that because it's a square root. We don't normally put a 2 where the square root is, but I did it today just to make sure that you guys could see it. So in reality, it's just the square root of 19. Now on this one here, it is the 4th root of 11 cubed. Can't simplify that. It's just whatever that is. This next part. Now the next part is tricky. The only thing that is to the 2/3 power is x. So it's going to be 14 to the cube root of x squared. Now because it's an x squared, I can't take that out because that's a cube root. Now this bottom part, it's going to be 5. Because the 5 is on the outside, it does not have it going to the 3/5. So on this next part, I'll change colors. It's going to be the 5th root of x cubed minus, now this one has 2x to the 3/5 power. So the way you can write that is 5th root of 2x to the 3rd power. So you can write it as that, no problems at all. If you want to go one step further though, you could do this. 5 times the 5th root of x cubed minus the 5th root of 2 cubed x cubed. If you want to, you could do that. You can even go further and it would be 5, the 5th root of x cubed minus the 5th root of 8x to the 3rd. So those are all correct answers. They all equal each other. All right, so it just depends on how far the answers are going. Now this problem here, you can't have a negative exponent. So you're going to put it under 1. And that's going to become 5/7. Now this one's trickier because you can't have, well, I'll show you. So they want us to actually write it out. So it's going to be 1 over the 7th root of x to the 5th. Now, you cannot have a radical in the denominator. So what you could do is rationalize this denominator. And by doing that, the 7th root of x to the 5th times the 7th root of x squared gives you the 7th root of x to the 7th, which means it's equal to x. So you could rationalize the denominator. And if you do that, you have to multiply this by x to the 2nd. So the 7th root of x to the 2nd, because it's going to give me x to the 7th. And when you take the 7th root of something that's to the 7th power, it's just x. Now, whatever you do to the bottom, you must do to the top. And you end up with the 7th root of x squared over x. Okay, so that is one way to do this problem. Now, the next problem here, that entire parenthesis will have a cube root. So this is going to be the cube root of x to the 3rd plus y to the 3rd, parenthesis, and you can put a 1 there if you want to. You don't have to put a 1 there, but I'm just showing you where the 1 went. Okay, so that's that one. We're still doing good on time. Now the next one, write each radical as an exponential. Simplify, assume your answers if you can. All right. The square root of 37. This 37 has an exponent of 1 on it. And that square root has an index of 2. So you can write this as 37 to the 1/2. Now this 9, what I highly recommend you do, because they're going to ask you to simplify it, I would take the 4th root of 9 to the 8th. This is what I would do first. If you have a number that you can simplify it now so it saves you time later. 9 can be written as 3 squared, okay? Now, I'm going to only work with what's under the radical. 3 to the 2nd raised to the 8th is 3 to the 16th power, okay? Now, my goal is to get a 4 here. So what I'm going to do is I'm going to manipulate it a little bit more. The 4th root of 3 to the 4th raised to the 4th. Do you believe that 4 times 4 is 16? It is. A power raised to a power, you multiply the exponents. So you got to play around with the numbers. So by taking the 4th root of this, it's going to leave you with 3 to the 4th power. 3 to the 4th power is just 81. Now let's do this one. Now this is an 8th root. So how do I say this? The 8th root of z to the 8th, it's just going to be z. Okay? And you know what? I just realized what I did. I simplified it without using the radicals or using the exponents. I just went a little crazy there for a second. I'm so sorry. This one would be 8 over 8, which is 1. So it's going to be z to the 1st. Let me redo this one real quick, just from where I'm here. So if I have, I'm going to start from right there, okay? I just went on to solve it. Don't know what I was thinking. But my base is 3. My exponent is 16. My index is 4. So you could just do this. It's way faster than all this work I did over here. And I get 3 to the 4th power, which is 81. That was funny. I'm so sorry. I just got a little sidetracked and kept on working on that part and didn't even think about it. All right, so if you wanted to look at that, you could. By using powers,